Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello students, welcome back to Crash King online class. In the last session, we have discussed about how to represent the given set in roster form, right? Okay, but in today's session, we are going to discuss about how to represent the given set in a set builder form, okay? Second form, that is a set builder form, okay? Yes. See, according to the definition of the set builder form, we are already discussed, okay? So here, instead of writing all the elements of the set, we'll represent it by a single common property, okay? Yes. So, I'll consider the problem related to set builder form. Write the followings in set builder form, okay? So, in that first one, set containing 3, 6, 9, 12, okay? So, here 4 elements are there. This set contains how many elements? 4 elements, okay? So, now how to write this given set in a set builder form? How to write it in set builder form? Okay, see here the first number is 3, isn't it? The first number is 3. Can I write this 3 as 3 into 1? Yes. Next, the second number is 6. Can I write this 6 as 3 into 2? Next, the third number is 9. Can I write this 9 as 3 into 3? 3 3s are 9, right? Next, the fourth number is 12. Can I write this 12 as 3 into 4? Yes. Here, all these first multiple is same, isn't it? A constant, right? The first multiple is same, right? So, I'll write it as a 3. But the second multiple is varying, right? The second multiple is varying. So, therefore, I'll write this second multiple as n. Okay? 3 is the first multiple, n is the second multiple, okay? Here n is nothing but this varying number, n is nothing but a varying number, okay? Yes. So now, how to write this given set in a set builder form? Set containing, instead of writing these 4 elements, I'll represent these all 4 elements by the single letter, that is x, okay? Such that what is the property of this x? X means these individual numbers. These individual numbers are in which form? Okay, such that x is equal to all these individual numbers are in which form? 3 into n. Okay, 3 is constant here, but n, the second multiple, is varying. So, I'll represent it by 3 into n. Okay, so comma, here n belongs to, which are the values of n here? N is nothing but which are the numbers? 1, 2, 3, 4, right? 1, 2, 3, 4. Okay, the value of n is varying from 1 to 4. Okay. Can you observe here all these numbers are natural numbers? Yes. So here n belongs to n. N means capital letter n. Also the value of n lies in between 1 and 4. Okay. So value of n lies in between 1 and 4. Okay. So the value of n is greater than or equal to 1, but it is less than or equal to 4. Okay. So this is known as a set builder form of the given set. Okay. Here instead of writing all these 4 elements, I'll represent it by a single letter, that is x. Then what is the property of this x? The element x is in which form? 3 into n. Okay. Here n is nothing but natural number, n belongs to natural number, and also the value of n lies in between 1 to 4. Okay, n value is greater than or equal to 1, but it is less than or equal to 4. Okay, so this is about set builder form. Okay, so next the second example I will consider here: 2, 4, 8, 16, 32. Okay, so how many numbers are there here? 5 numbers are there. Okay, so what is the property of these 5 numbers? The first number is 2. So that 2 is nothing but 2 to the power 1, isn't it? 2 to the power 1, how much? 2. Next, the second number is 4. Okay, so that 4 is nothing but, can I write it as 2 square? Whether 2 square equal to 4? Yes. Next number is 8. So 8 equal to 2 cube. What is the value of 2 cube? 2 cube is nothing but 2 into 2 into 2. 2 2s are 4, 4 2s are 8, right? Next number 16. Okay, so 16 is nothing but 2 to the power 4. Okay, next 32. Okay, so whether 32 is nothing but 2 to the power 5, multiply 2 5 times, whether you will get 32? Yes. Multiply 2 5 times, you will get 32. Next, multiply 2 4 times, you will get 16. Next, multiply 2 3 times, you will get 8. Next, multiply 2 2 times, you will get 4. Again, multiply 2 1 times, you will get 2. So, what is the form, general form of this expansion? How to give? See, in each form, can you observe here, the base value is constant 2, 2, 2, 2, 2. Base value is constant, isn't it? Only the exponent value is varying from 1 to 5, isn't it? Exponent value. So, I will represent it by 2 to the power n. Okay, I will represent it by 2 to the power n. Okay, so here the value of n is varying from 1 to 5. Okay, yes. So now here 5 elements are there. So how to write it in set builder form? All these 5 elements I will represent it by single letter, that is x. So what is the property of this x? X equal to these 5 elements are in which form? 2 to the power n, 2 to the power n. Also n belongs to natural number. Also the value of n lies in between 1 to 5, isn't it? 1 to 5. So therefore the value of n is greater than or equal to 1, but it is less than or equal to 5. Okay, the value of n is greater than or equal to 1, but it is less than or equal to 5. Okay, so this is known as a set builder form of this given set. Okay, so similarly I will take few more examples. So the next third example I will consider: 5, 25, 125, 625. Okay, yes. So how to write it in set builder form? See, the first element is 5. Okay, the first element is 5. Okay, so 5 is nothing but 5 to the power 1. 5 is nothing but 5 to the power 1, isn't it? So next number is 25. 25. This 25 is nothing but 5 square, isn't it? What is the value of 5 square? 5 square equal to 5 into 5 equal to 25. So the next number is 125. Okay, so 125 is nothing but 5 cube, right? 5 cube. If you multiply 5 3 times, 5 into 5 into 5 equal to 125. Next, 625. 625 equal to 5 to the power 4. If you multiply 5 4 times, you will get 625. Okay, if you want, you can check out. Multiply 5 4 times. What is the answer? 625 you will get. Okay, yes. So again the same concept here. See, the value of base is the same. Okay, what is the value of base here? 5, only the exponent value is varying. Okay, so therefore I'll write 5 to the power n. Okay, also which are the values of n here? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so the value of n is varying from 1 to 4. Okay, yes. So now we'll write this set builder for, okay, this is equal to set of all, okay, x, okay, such that what is the property of this x? X equal to your element x is in which form? 5 to the power n, 5 to the power n. Also here n is nothing but natural number, isn't it? The value of n is 1, 2, 3, 4. All these 4 numbers are natural numbers, isn't it? Okay. Also the value of n lies in between 1 to 4. Okay. So therefore the value of n is greater than or equal to 1, but it is less than or equal to 4. But it is less than or equal to 4. Okay. So here n belongs to n. Okay. This is set of all natural numbers. Set of all natural numbers. Okay. So this is about set builder form of this given set. Okay. So similarly I will consider another example, 2, 4, 6 and so on. Okay. Yes. So again the first element is 2. Okay. So can you write this 2 as 2 into 1? Next, the second element is 4. Can you write this 4 as 2 into 2? Next, the third element is 6. Can you write this 6 as 2 into 3? Again, the same process is continuing here. So all these elements are in which form? Here the first multiple is 2, isn't it? So the first multiple is constant here. So write it as it is. Only the second multiple is varying. So therefore I'll represent the second multiple by n. Okay. So here which are the values of n? N is nothing but 1, 2, 3 and so on. Okay. Yes. So now I'll write the set builder form. This is equal to set of all x such that x is equal to, okay, all these elements are in which form? What is the general form? 2 to the power n. Okay. Here n is nothing but 1, 2, 3. Okay. All these numbers are natural numbers. So n belongs to n. Also the value of n is varying from where to where? Starting from 1, isn't it? Starting from 1. But what is the highest number or what is the last number? No, we cannot find, because here infinity, what it means? Dot 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 means it's so on. That process is continuing, isn't it? So therefore what I will write here? The value of n is greater than or equal to 1. Okay. Here I can write what is the last number? 4. But here do you have last number? No, isn't it? So therefore what I will do here? N value is greater than or equal to 1 I will write. Okay. The value of n is greater than or equal to 1. It is starting from 1, 2, 3, 4, 5, like that it will continue. Okay. So therefore what is a set builder form? X such that all these elements are in which form? X such that what is the property of that x? X is equal to 2n. Okay. All these elements are multiple of 2. Okay. All these elements are multiple of 2. Okay. Such that n belongs to n. The number n belongs to n. N is nothing but natural numbers, comma. Also the value of n is varying from 1 to infinity. Instead of that you can write n is greater than or equal to 1. Okay. So this is about the set builder form of the given set. So the next problem, list all the elements of the set, list all the elements of the following set. Okay. You have to list all the elements of the following set. Okay. Yes. So the first problem, set A is equal to set of all x such that x is an odd natural number. Okay, so you have to choose an element. Which elements you have to choose? That element must be an odd natural number. Okay, so which are those elements? See, A is equal to odd natural numbers. You have to choose an odd natural number. The first number 1, right? Obviously 1 is an odd number. Next, what is the next odd natural number? 3. What is the next odd natural number? 5. Next 7. Okay, so whether they have given any condition here, where to where you have to choose? No, right? So no problem. Write dot dot dot. Okay, what it indicate? So on, continuing. Okay, etc. Okay, so which are the odd natural numbers here? 1, 3, 5, 7 and so on. Okay, yes. So this is about this is the answer for the first question. So similarly we will consider this second one. B is equal to, set B is equal to set of all x such that x is an integer. Also one condition they have given. What is that condition? X square, the square of that number less than or equal to 4. Okay, so you have to choose an integer in such a way that the square of that integer must be less than or equal to 4. Okay, so integers you have to choose. Okay, so I will consider 0. Okay, whether 0 is one integer? Yes. Okay, so 0 square equal to how much? 0. Obviously 0 is less than 4, isn't it? So therefore I can choose that 0. Okay, so B is equal to 0. Okay, next integer I will consider 1. Okay, what is the value of 1 square? 1 square, you have to consider square of a number. Okay, 1 square is nothing but 1. Obviously 1 is less than 4, so therefore this 1 we can include that 1. Okay, so next I will consider minus 1. I will choose minus 1. Okay, so minus 1 whole square. What is the value of minus 1 whole square? Minus 1 whole square is nothing but minus 1 into minus 1. Okay, minus into minus plus, you will get plus 1. Okay, yes, again 1, whether this 1 is less than 4, yes, so therefore minus 1 also possible, minus 1 also possible. Next number I will choose 2. Okay, 2 square equal to how much? 4. Okay, yes, you have to choose a number in such a way that square of that number less than 4 or equal to 4. Okay, so here equal to 4, so therefore again 2 is possible. I can include that 2. Okay, so next minus 2 I will choose, minus 2 whole square. Okay, what is the value of minus 2 whole square? Minus 2 whole square is nothing but minus 2 into minus 2. Okay, minus into minus plus 2 2s are 4. Again I will get 4. Okay, so can I choose this minus 2? Yes. Can I choose this minus 2? Yes. So minus 2 is also possible. Is there any other number? If I choose 3 square equal to how much? 9, but 9 is greater than 4, isn't it? So therefore this is not possible. Okay, the square of that number must be less than or equal to 4. Okay, so therefore 3 not possible. So therefore only till minus 2. Till minus 2. Okay, so which are the elements will comes under this set? 0, 1, minus 1, 2, minus 2. Okay, so there are totally 5 elements. Okay, yes. So next we'll consider third problem. Third problem I'll consider. C is equal to set of all x such that x is an integer. Also the value of x must be greater than minus 1 by 2 and less than 9 by 2. Okay, minus 1 by 2 means what is the value of minus 1 by 2? That is nothing but in decimal form minus 0.5, isn't it? 1 by 2 is nothing but 0.5, right? Okay. Less than x, less than 9 by 2 is nothing but 4.8, right? 9 by 2 means in decimal form 4.8, sorry, not 4.8, 4.5, right? 4.5, right? Okay. So now, according to this question, you have to choose an integer in such a way that that integer must be greater than minus 0.5 and it is less than 4.5. Okay, yes. I'll consider one number line. This is your number line. So here 0, 1, 2, 3, 4, 5, minus 1, minus 2. Okay, yes. So here minus 0.5. Minus 0.5 means here 0, minus means left side direction. Okay, so minus 0.5 means somewhere. So minus 0.5, isn't it? So here it will come. Next 4.5 means right side. Okay, 4.5 means here, it may come here. Okay, 4.5. Okay, yes. So now you have to choose an integer in between minus 0.5 and 4.5. Okay, so which are those integers? This is equal to C equal to, this is minus 0.5. Next which integer? 0. Next 1. Next 2. Next 3. Next 4. Can you choose 5? No. Okay, till 4.5, less than 4.5 means till 4. Till 4 you have to write. Okay, yes. So this is about to answer for the third question. So next, fourth question I will consider. D is equal to set of all x such that x is a letter in the word loyal. Okay, yes. So it's very easy. So D is equal to, okay, which are the letters? The first one is L, the second letter O, next third letter Y, next fourth letter A, next fifth letter again L, but L already I have written, so don't write twice. Okay, only once you have to write. The elements of the set will never repeat. Okay, so therefore only once you have to write. So therefore what is the answer? L comma O comma Y comma A. Okay. The next question I will consider. Set E is equal to set of all x such that x is a month of a year not having 31 days. Okay, so which month of a year does not have 31 days? Okay, so which month? So set E is equal to set containing, can I choose February? Yes, February. Next which month? April will come. Next April will come. So after April which month will come? June will come. June. Next after the June which month does not have 31 days? After June? September. Next September will come. After September, November. Okay, next. Okay, so there are totally 5 months. Okay, February, April, June, September and November. Okay, so totally these 5 months of a year not having 31 days. Okay, that does not have 31 days. Okay, so next another question. F is equal to set of all f is equal to set containing x such that x is a consonant in the English alphabet which precedes k. Which precedes k. What is the meaning of this? First I will write the English alphabets. Okay, yes. So A, B, C, D, E, F, G, H, I, J. Can I consider K? No. Precedes K. means till J only I have to consider. Okay, what is the previous alphabet? That is J, isn't it? The previous alphabet of K is J. So from A to J, I'll consider English alphabets from A to J. Okay, yes. So now, among these alphabets, which alphabets are known as a consonant? First, I'll choose vowels. You already studied about vowels, right? Okay, so which are the vowels? A, E, I. Isn't it? A, E, I. These three are vowels, isn't it? So, except these three vowels, which are the remaining alphabets? B, C, D, F, G, H and J. So, these alphabets are known as consonant. Okay. So, which are the consonant will come? F is equal to B, comma, C, comma, D, comma, F, comma, G, comma, H, comma, J. Okay. So, this is the answer for this given set. Okay. So, next we will discuss about important definition, that is about empty set. Okay. So, what do you mean by empty set? A set which does not contain any element is called the empty set. Okay. If your set does not contain any element, okay, then such type of set is known as empty set. Okay. What is another name of that empty set? That is null set. We will also call it as null set or void set. Void set. Okay. So, these three are same: empty set or null set or void set. Okay. So, it is denoted by, the empty set is denoted by, either we can denote it by line or we can denote it by this symbol. Okay. Yes. See, I'll consider one example. Okay. Let set A is equal to set of all x such that x belongs to n, that x must be natural number and the value of x must be greater than 1 and it is less than 2. Can you choose any natural number in between 1 and 2? Do you have any natural number in between 1 and 2? No, right? So, therefore, this is an example for null set. We will give set A is equal to empty set because we cannot find any element in between, we cannot find any natural number in between 1 and 2. Okay. So, therefore, set A is nothing but an empty set. Okay. Yes. So, similarly, the next definition, important definition, that is about finite and infinite set. Okay. What you mean by finite set and what you mean by infinite set? Okay. Yes. So, the name itself indicates finite set means a set which is empty. If your set is empty, then we will also call it as a finite set, or another condition, or it consists of a definite number of element. It consists of a definite number, okay, some countable number, okay, or finite number. Okay, yes. So, it consists of a definite number of elements is called a finite set. Okay. If the set is not finite, then it is known as an infinite set. Okay. Otherwise, it is called infinite set. Okay. If your given set is not finite, then it is known as infinite set. Okay. So, example 1 I will consider. Set A is equal to set of all x such that x belongs to n, your x must be natural number and also the value of x must be greater than 1 and it is less than 4. So, which natural numbers is equal to, the natural number must be greater than 1, so 2, next it must be less than 4, so 3 is possible. Can I choose 4? No, because your natural number must be less than 4. So, therefore, which are the natural numbers? 2 and 3. Can you observe here, this set A contains only 2 numbers, only 2 numbers, yes. So, therefore, this is a finite set. Okay, the example 1 is an example for a finite set. Okay, why it is finite set? Because the elements of the sets are definite or countable. There are only 2 elements, isn't it? So therefore this is a finite set. Okay, next another example I will consider. B is equal to set of all points in a line. Okay, I will consider one straight line. Okay, so you have to count up points on this line. Can you count? There are infinitely many points are there. There are infinitely many points lies on this line, straight line. It is we cannot count, isn't it? So therefore this is an example for infinite set. Okay, the points on this line. Okay, the points on this line, it is infinite. Okay, it is infinite. So therefore this given example 2 is an example for infinite set. Okay, so this is a infinite set. Okay, so example 1 is an example for finite set, example 2 is an example for infinite set. Okay, so this is about finite set and infinite set. Students, in the next session will solve the problems related to empty set and finite and infinite set.
Don't forget to like our video and subscribe our YouTube channel for all the updates.